Hi, hello everybody, hello. Hi. Hey, good evening, all of you, good evening. Morning, huh? Not morning. Very good evening, Andariki. Hi. How are you all? Hey, am I audible and visible? Cheppandi okasari. Hi, Hima. Hi. Good evening, Prasad. Good evening. Good evening, Gonad. Good evening. Okay. So, can we continue? Huh? ఒకసారి చెక్ చేసుకోండి. Am I audible and visible? Audio video clear కదా? Good evening, all of you. Good evening. Yes, I'm fine. Yeah, I'm fine. So, start చేద్దాం. చెప్పండి అందరికి ఒకసారి. Oh, nice. Okay. Okay, Vikshita. Okay. Scene. Okay. Give me 1 minute. 1 minute. Okay. Nice. Good evening, all. Good evening. Hello. Hi. Hello, Maitri. Good evening. Okay. Oi, so shall we start? Do you have any problems? Cheppandi. So if you don't have any problems, we can definitely start, sir. Good evening, sir. Good evening, all of you. Good evening. Don't know what's happening. Okay. So let us continue, okay? Hi. Hey, what are you talking? Huh? Now, sir, I remember you look like Sandeep Pradeep. Who is he, Re? Huh? Who is he? Why are you comparing me with anyone, huh? Someone is telling I look like Arjun Sarja. Someone telling I look like that brother of some actor. Some look like. Anyways, so let us start, okay? Start with the mandari. So, we will jump on PYQ later on, right? Okay? Because the concepts are remaining, kada? So we can't leave the concepts and jump directly to PYQs. Okay, we will take it. What MCQs, Gonat? What MCQ are you talking about? Good evening, Soumya. Good evening. Okay. Okay, so shall we start? Chusko. So let us do a quick recap. Right? What did we study? Okay. All the formulas. So first one is we studied about forces, kada. So forces lo kuda we studied about the string force, gravitation. Yes, gravitation has at least one question. Okay, one question. Okay. So first we discussed about tension. Ante kada. Tension ante entira. So if this is a ceiling ring, hey, చూసుకోండి అందరికి. This is a block of mass 10 kg. And the tension in the string was coming out to be 100 Newton. అంతే కదా? Too much thick, right? Too thick. Right. దాని తర్వాత we talked about spring force రా. చూసుకోండి. Spring force formula ఏంటి రే? Formula F is equals to K into X. అంతే కదా? So this was my natural length of the spring రా. So ఇదే నా natural length L0. What I did is I pulled it. Pulled it there. I have expanded or elongated it. Elongation. So ఇదే నా elongation. అంతే కదా? X పిలుస్తారు. So ఇక్కడ నుంచి simply చేస్తారు force by spring is equals to K into X. Be it elongation, be it compression రా. Okay. Okay. So if it's a compression ray, దీంట్లో కూడా same story రా. What sir? This is my compression X. Again the force is equals to K into X. Ante kada? Yes. Now let us talk about gravitational force rate. Okay? Gravitational force. Chuskondi andariki. Gravitational force ante enti sir? Whenever you have an object, chuskondi. Hey. Okay. So all the times mass m unde there will be a force in the downward direction ra, mg. In the mg, g ante enti re? G ante acceleration due to gravity. We will study about it in gravitational chapter in detail ra. Variation in the value of g. Ante kada? G value enti ra? It is generally 9.8 లేదా you can also take it to be 10 meter per second square. Okay. మామూలుగా we will take 10 meter per second square only. ఎందుకంటే we have to do the calculations కదా. So to ease up the calculations we will be taking the value of g as 10. Good. Always acts downwards. అంతే కదా? చెప్పండి. So if mass is 20 kg రా, force ఎంత రా? So F is equals to m into g sir. అంటే 20 into 10 అంటే 200 Newton. అదే కదా? So ఇదే నా ఫోర్స్ రే. ఏం ఫోర్స్ రా? గ్రావిటేషనల్ ఫోర్స్. mg always acts in the downward direction. Value is mg రా. Good. ఎక్కడ కూడా చెప్పండి. Can I directly say force is equals to 1000 Newton రా? అంతే. Next, wedge block scenario. ఇది చాలా ఇంపార్టెంట్. It's very important scenario. Listen to me. Okay? Hi Vikshita. Hi. చూసాను. What happened to me today రే? ఏమైందిరా నాకు? So mass m తీసుకోండి. Okay? Mass m is there రే. Hey, you remember the proof. If you don't remember the proof, at least remember the results. Okay? At least remember the results. ఎందుకంటే these are very general and very important results for you to remember. Okay? So remember this. Remember all of these things. Okay. Point number 1 ra. Sir, either na mass m unte, what will be the force acting on this mass? Pen is too thin ra. Okay, let us keep this much. Okay. So there is a force acting in the downward direction. Kindagi enta ra? Mg kada? Yes. So I'll take the ink only. Okay. So idhe na force ra. So this is my force mg. Agreeing students? Agreeing. Good. Hey, focus here, Ray. Okay, yes, focus here. Okay, good. So mg ante downward direction ra. So sir, if the force is acting downward, why is it not moving downward? Why is it moving in the slanted direction, Ray? Huh? If the force is acting downward, why is this block moving in a slant? Component of force is there. So we resolve the forces for that reason only. We resolve the force for that reason only. Enduku resolve chestunarra? If force is acting somewhere, if force is acting in one direction and motion is in another direction, then we take the component. Then we take the component of that force in that direction. Cheppu. Ikkada vachi, you can simply say, sir, this will be the first component and this will be the second component. Ante kada? Idigo. This angle theta kada. Similarly, you can also say this angle is also theta. Hey, geometry ra. Geometry. I'm telling you believe it. Okay, I'm telling you believe it. Chuskondi. So now you can simply say, sir, ide na main force mg. This is the adjacent component and this is the remaining component. What did I say? What did I say? What did I say? For adjacent component there will be cos, and for opposite component there will be sin kada. Yes, great. Great. Ante ee force ki value ante mg into cos theta ra. And this force will be mg into sin theta. Hey, chuskora. This is known as my wedge ray. Hey, wedge ante enti ra? Wedge ante enti? You say what you should say. What is wedge ray? Wedge is the shape. Okay, you just visualize it. It could be made of. Usually it should be smooth. Okay, okay. It's just like your slant hydra. I'm not remembering the name. Okay, you just understand. This is the wedge. This is the wedge. So, ante eppadaina na daggara oka wedge block system unte, this is known as the angle of inclination theta ra. I'm putting a block of mass m. Cheppandi force in the slant downward direction, not downward. Downward is mg only. Chuskondi. Downward is mg only. And in this direction, force value is m into g into sin theta. Ade. Okay, sir. What about this direction? This value will be m into g into cos theta. Gurtpettukondi. Always remember. Hey, always remember. Whenever you have a wedge, force in the cross side downward will be mg sin theta. Always, always, always. Ante kada? Okay. Good. Next. Next, let us take a question. Okay. A block of mass 20 kg placed on a wedge of angle of inclination 30 degrees with the horizontal. With the help of a string as shown, find the tension in the string. Naku tension kavali ra, chuskondi. So this is my wedge. Okay, angle of inclination is 30 degree. Here, I am attaching a string ray. Hey, chuskondi. So ide na string. Mass entara 20 kg. So ikkada mass is 20 kg ra. Cheppu. Naku tension kavali ra string lo. Tension how much? Enta vastundi ra? Huh? Good. Yes. What are you talking? Cheppo. So, sir, there will be this force mg sin theta. Ante kada? Yes. Mg sin theta. Values pettora. Huh? Value substitute. Mass is 20. G is 10. Sin 30 ante half. Ante kada? So, ante 100 Newton of force is acting on this block in the downward direction. And the block is at rest. Ante tension is acting in the upward direction. Opposite to the object. Okay? Good. Very good. Very good. Very good. Ante tension in the string will be again 100 Newton. Ante kada? Yes. Ide same question I will try to solve it by applying a spring ra. Okay? Instead of tension, spring force is there. Chuskondi. Ade same question. Only thing is, string will get replaced by a spring. 20 kg mass. K value antara. K is equals to 100 Newton per meter. Cheppandi andariki. Cheppandi. Elongation in the spring kavali. Elongation in the spring kavali. Cheppandi andariki. Cheppo. Correct? Good, good, very good. Andariki very good. 1 meters, yes. Hey, you focus here. For all those who are not understanding these questions, Cheppandi, here the force acting is mg sin theta. Ante same 100 kada? Yes, 100 Newton. So attach chesi, immediately what happens is the spring will get elongated. Ante kada? Elongated ante final position lo spring is applying the force in the upper direction and gravity in the downward direction. Ante both forces will be equal ra. Cheppu, spring force enta ra? Always you can say k into x is the spring force. It should be the opposite force, 100 in the downward direction. Equilibrium, rest, balanced forces ra. So ante 100 into x is equals to 100. Ekkad nunchi x is equals to 1 meter. So 1 meter is the elongation. Chuskondi. Ippudu let us talk about contact forces. Hey, the discussion is going towards a very important topics. Andariki chuskondi. If you are done with these topics, dan tarvata you are open to solve all the questions, right? Okay, so let us do one thing. Okay, let us do one thing. Okasari our chapter is completed, we will take a full separate dedicated session on PYQs only. Okay, yes, I will try to add PYQs also. Kani chuskondi. Hey, contact force ante entira normal reaction kuda antaru. Contact force ante enti sir? Contact ante whenever there is a contact of two surfaces. Two surfaces ante entira? Two surfaces ante if you are pushing this wall, right? Hey, chuskora. If you are pushing this wall will push you kada. If you are pushing this wall will also push you. Chuskondi ra. Okay. Hi Isha. Hi, good evening. Hi. Okay. So contact force ante enti? It always acts between the two surfaces. Chuskondi. Okay, not two surfaces, always associated with a surface ra. Okay, property gurtu petukora, associated with a surface. Ante enti, if I am putting a block of mass m on the ground, chusko mg downward act chestunnaru kada, and to balance this force, ante is this block moving downwards? No. Epadaina whenever you see a mass is at rest, you remember my words. Hey, you mark my words. Whenever you see a mass is at rest, okate meaning for that is the net force on that block is zero. Net force ante enti sir? The resultant of all the forces. So sir, here the mass is at rest. One force is in downward direction. Mass at rest. Only one force in the downward direction. Possible? Not possible. So what's happening there? That means the surface is applying a force in the upward direction. Yanta force, sir? Normal reaction is the name and the value is equals to mg ante gravitational force. Chuskondi andariki. Hi, all of you. Hi. Good evening. So ekkada vachi normal reaction is equals to mg. Cheppora. So let us say I have two blocks now. Hey, let us see how many of you can tell me. Okay, let us say I have two blocks ra. E block ki mass ante 20 kgs and the mass of this block is 10 kgs. Point number 1, question number 1, tell me how many normal reactions are there? Enta normal reactions ostundira? Cheppu. How many normal reactions will be there? 1, 2, 3, 4, 5, 6. How much, Ray? How much? 2 normal reactions. Ray, is it visible? Masses are visible, kada? Yes. 2 normal reactions, right? 2 normal reactions. First normal reaction will be directly on 20 kg block by the ground, ra. Chuskondi. So idena normal reaction N1 ra. Ante kada? And the second normal reaction will be N2 over here. Ide. Understanding N1 N2 ke values entira? Not 1. 2 normal reactions are there. 2. Wherever the surfaces are in contact, there will be going to be a normal reaction force. Okay. Cheppandi here. Talking about N2 ra. N2 gurinchi maatladutunnam. Chuskondi. N2 ante How is N2 created, ra? Ante N2 is balancing what mass? N2 is balancing what mass, sir? Sir, N2 is acting on 10 kg. Ante ippudu I will draw the diagram of 10 kg block, ra. Chuskondi. So ide na 10 kg ki block. mg force ante 100 Newton kindaki act chestunnaru. To balance this 100 Newton force, there is a normal reaction by 20 kg block. N2 is equals to 100 Newton. Ante kada. So now come to this lower block, ra. So I'm talking about 20 kg block as a whole, right? Cheppandi. So 20 and 10 ante kada. Ground, ra. Ground. Idi na land, ground, earth. How many blocks is the earth balancing? Both the blocks. Good, very good. Good, very good. So this earth is balancing both the blocks. Ante total mass of the both blocks 300 Newton is the gravitational force. Ante kada. Okay, చూసుకోండి రా. 10 plus 20 అంటే 30 kgs in total. And total normal reaction is not normal reaction, right? So total mg అంటే 300 Newton. And ఈ 300 Newton ని బ్యాలెన్స్ చేయడానికి there will be a normal reaction by the ground. N1 is equals to 300 Newton. అందరికి you understand this process, okay? I have seen multiple students who do not understand these things only. So ఇప్పుడు నార్మల్ బై వెడ్జ్ గురించి మాట్లాడతాం, చూసుకోండి. అదే సేమ్ సినారియో రే. యాంగిల్ ఆఫ్ ఇంక్లినేషన్ తీటా తీసుకోండి. హియర్ ఇస్ ద బ్లాక్ ఆఫ్ మాస్ m, అంతే కదా. హౌ మెనీ ఫోర్సెస్ రే? హౌ మెనీ ఫోర్సెస్? హాయ్ శాలిని, గుడ్ ఈవినింగ్. Good, very good. Darken, very good. Good. Prasad, very good. Okay, so here ekkada vachi cheppandi ra. So the first force, sir, acting is mg sin theta. Chuskora. This force mg sin theta has nothing to do with normal reactions, ante kada, because it is acting parallel to the surface. Okay, this force is acting parallel to the surface. But చూసుకో, when you talk about this force ray, this is mg cos theta kada. Yes sir, this is mg cos theta. It is acting on the surface ray. So to balance this mg cos theta, ఇది wedge కూడా ఒక force exert చేస్తున్నారు రా. Are you understanding? Wedge will also exert a force. Sir, am direction లో force, sir, that force by the wedge will be opposite to the mg cos theta. Ante this will also be equals to mg cos theta. Chuskondi, chuskondi. Along this line, there are two forces. mg cos theta, balanced. That is why the block is not moving up and down. This block, mass m, is only moving downwards. Endukante okate force untundi ra, mg sin theta. Here mg cos theta is there. Gravity component. Kani ee force ni balance cheyadaniki one more force is there, mg cos theta. They are opposite. Understanding. So normal reaction by wedge is always given as m into g into cos theta. Ade. Are you understanding? Good. Ardham raledu Gunat. Can we consider components as different forces? Yes, absolutely. So when you're talking about mg sin theta and mg cos theta, original force is gone. Original force enta ra, mg ante kada. So if you are talking about these two, you don't have to consider mg will be gone. If someone says mg sin theta also, mg cos theta also, gone, right? That person is gone, okay? You only take either the total force లేదా components of that force ra, but don't take both together, okay? Good. So let us talk about some mixed concepts. Mixed concept and enti sir? Spring plus gravity plus normal. I will be asking you those types of questions, okay? Only two forces, Gonat. 1, 2, ade. Three forces. So what I'm doing now is, you understand, okay? You try to understand this scenario. Ide theta angle. This is my mass m. Total forces on this mass ante, you have two different scenarios. Rendu rakal scenarios unnai. In first scenario, you only talk about gravitational force, mg, ade. Are you understanding? You only talk about gravitational force and the normal reaction by the wedge. Ade normal reaction mg. It is the first case. కానీ చాలా కాంప్లికేటెడ్, ఎందుకంటే the forces are not properly aligned. So ఏం చేస్తారు ఇప్పుడు? You break this mg force రా. Now what you do is you break the mg force. ఎలా బ్రేక్ చేస్తారు సర్జీ? This is mg sin theta అంతే కదా. So ఈ force mg sin theta along the incline రా. And one more force is mg cos theta. So if force ki place I am writing these two forces. And other force by the normal reaction. Normal reaction is independent. Hey, చూసుకోండి రా. Normal reaction will always act. Normal reaction is equals to mg cos theta. ikkada kuda the same force. Here also the normal reaction is mg cos theta. Ade. Understanding? So you can take this or this, but don't take both. Okay? You can take this or this, but don't take both. Good. Yeah, Bhavani, you're saying something? Good. Good, Ra. So let us talk about mixed concepts. Now I'm giving you questions, Ra. Questions teeskondi. Number 1. Find elongation let us start from basics. Okay? Hey, let us start from basics, ra. Very basics. Chuskondi. So ide na spring 10 kg ra. Hey, 10 kg block. Here is my string ray. Again malli 10 kg. K is equals to 100. Hey, all the times, okay? Wherever you are seeing the spring, take the value of spring constant as 100. Okay? Spring constant ki value ni 100 తీసుకోండి. ఎప్పుడైనా ఎక్కడైనా. For my class, I will give you K value as 100. Mostly 100. ఎందుకంటే we want simpler calculations కదా. Yes. Great. తీసుకోరా. Next question. So next question లో I'm giving you a wedge ray. Okay? So instead of a block, ఒక wedge తీసుకోండి. Let us say angle of inclination is theta. Here also ra. And ekkada I am attaching a not spring. Initially let us talk with the string ray. String. So idena string. Chuskondi andariki. 10 kg block ra. Okay. This is my spring now. Again malli 20 kg block. Cheppandi. K is equals to 100. Tondarga cheskora. We don't have much time. Okay. Tondarga cheskondi. And tell me the answer. Hi. Good evening Lakshman. Tell me quick. Third scenario. Okay? Third scenario. So dan tarvata we just have to jump to Newton's first law. This is all the basics of the first law. Forces gurunchi information. What type of forces? 4 forces. Normal, contact, gravity, string. Normal, string, spring, gravity. Ade. Good. Let us see. In the scenario, so this spring ray. Hey. In this scenario, a spring, he is supporting both the blocks. Sir, ela cheptunnaru sir? How is the spring supporting both the blocks? Do one thing, cut it. You cut it. Cut chesi, which blocks are falling down? Rendu blocks. Ante, this spring is supporting both the blocks. Kada? Yes. So you take initially up to down. We are going up to down. Ante kada? We are moving up to down. Ra. So ide rendu blocks ante total mass is 20 kg. So total gravity on both the blocks is mass into G. Ante 20 into G ante 200 Newton. So total blocks lo downward kindaki force ante 200 and paina force ante spring force. So sir K into X is equals to 200 ante kada. So ikkada nunchi X is equals to 2 meter directly. Good, very good. Ide kada. Now we talk about this ray. Hey, you talk about this. Always move up to down. Always move up to down. Cheppo, in the scenario, 100 Newton in the downward direction. Ante kada? And tension is only acting in the upward direction. Sir, which one? Bhanu, which one? Here, 2 meters. Tension is not 200. 100 in the downward direction, and tension will be 100 also. Chuskondi. So tension is 100, not 200 ray. If you are not understanding this question, Try some more. Okay, good. Ekkada cheppandi. Here the same thing. Write the forces on the masses. Masses పై యాక్ట్ చేస్తున్న ఫోర్సెస్ కి రాసుకోండి మొదటిగా. దట్ ఈస్ ద ఫస్ట్ స్టెప్. దాని తర్వాత ఒక్కొక్క బ్లాక్ ని తీసి ప్రాపర్ నెట్ ఫోర్సెస్ హౌ మెనీ ఆర్ యాక్టింగ్, విచ్ ఆర్ దే, you see later on all of those things. But firstly, write the forces, ra. Okay, good. So here, tell me, ra, sir, the force that is acting here is mg sin theta. Always. Okay, good pettukondi ra. Okay. See, ide questions ni there is also one more way to solve. Free body diagrams antaru. Okay, but it's very complicated. What will you do, Ray? You will consider each and every block. Sir, on this 10 kg block, T1 acting downward direction, Kx acting upward direction, Mg acting downward direction. Take the equations, write it. Are you understanding? The best way is to assume the big masses, ra. Big masses ante enti? In this question, the question you assume the big mass ante total system like this. How much? 10 plus 20 kada? 10 plus 20 how much? 30. Yes. So 30 into sin theta acting in the downward direction, tension acting in the upward direction. That's why I'm telling. Kabatti cheptunnanu. Start from the topmost position. That's a very simplified way. Okay? Always start with the topmost position. Good. Cheppura. So 20 plus 10 ante 30 ante total force is mg sin theta ra. For the whole system I'm writing. Chuskondi. mg sin theta ante 150 kada? Yes. So sir, tension in the string will be equals to 150 Newton. Edaina. How many of you are getting 150 ra? Good. Gonat, very good. No, Banu, tension is not 300 mg. It's not mg force, it is mg sin theta. Here it is mg. ఎందుకంటే ప్రాపర్ వర్టికల్ కదా, కానీ హియర్ ఇట్స్ అ వెడ్జ్. సో టోటల్ mg will be downwards. Component mg sin theta will be in the downward direction. Good. Here focus on this part now. చూసుకోండి రా. K into x will be acting in the upper direction. 20 kg block mg sin theta 100 into 200 into sin 30 అంటే 100 Newton. Only 100 Newton is acting on this 20 kg block రే. చూసుకోండి. Only 100 Newton is acting on this 20 kg block in the downward. ఈ 100 ని బ్యాలెన్స్ చేయడానికి you have spring కదా. So spring is acting K into x force in the upward direction రా. చూసుకోండి. So 100 is equals to K into x అంటే 100 is equals to 100 into x. X is equals to 1 meters. Tension 150. Hey, 150. X is 1. Good. Hey, do you have some time, Ray? Okay. Next question. Let us talk about next question now. Okay? Wherever you see K, always 100. Okay, this is 20 kg ra. 10 kgs. Here also 20 kgs. చెప్పండి అందరికి. Start from the top, Ray. Hey, start from the top. Always remember, if you're starting from the bottom, it will be very complicated. Understanding, you will have to consider this, dan tarvata this. That means it is going to be very complicated. Other chapter, no, start from the top. Top ante Consider the total system as 1 mass. Consider the total system as 1 mass. Okay? So let us do one thing. I'll copy it. Alright. Chapura. Let us take here only. Okay? I'm writing this question here only. Hundred. Okay? 20, 10, 20. Top nunchi start cheyandi. From top ante entira. You imagine idi 100 kada spring constant. Idi kuda 100 ra. So when they are in parallel, em cheyali ra? When they are in parallel, simply add them. Yes, 200. Ante you replace these two systems. You replace these two systems with a one system, one equivalent system ra. Chappura. So you can simply say this is one equivalent system. K is equals to 200 Newton per meter. Ante kada? Yes. Point number one. Good. Now consider the total mass. Total mass is 40, 10, 50 kgs. Ante mottam 50 kgs is the mass. mg ante 500. Okay? mg ante 500 Total mass is 500. This cheppandi. So is spring lo total elongation entara? Total mass is 500, sir. So 500 in the downward direction and upward direction is k into x. Ante kada? So k into x is equals to 500. K value entare 200. 200 into x is equals to 500 and x is equals to 2.5 meters. Point number 1. Chuskondi andariki. Ardhamaindi. Next, let us leave this block and slowly we are shifting down. Cheppandi. Here for this string ray, if I cut it, what is falling down? Rendu blocks. Ante a string, it is supporting both the blocks. Ante 300 Newton of force, 30 kg kada. So the string is supporting 30 kg mass. Ante the total mass now come in the scenario. ఎప్పుడు దీంట్లో చెప్పు 10 plus 20 అంటే 30. 300 in the downward direction, tension in the upward direction. అంతే కదా? So tension in the upward direction and 300 in the downward direction. అంటే tension is equals to 300. Finished. Easiest ways. Okay, easiest ways. దాని తర్వాత go to the lowest block. Lowest block. ఇదేనా lowest block కదా? Yes. So initially I took total blocks. దాని తర్వాత skipped the upper block. Only these two. దాని తర్వాత only lower block. అంతే కదా? Yes. చెప్పు. 20 kg అంటే 200 Newton in the downward direction and k into x in the upward direction. అంతే కదా? Yes. So చెప్పురా. Sir, k into x is equals to 200 and x is equals to 2 meters. Finished. So x1 ఇదిగో x2. You can take x1 and x2 values. Good. Okay, let us move to the next part. చూసుకోండి. ఫాస్ట్ లా గురించి మాట్లాడతాం ఇప్పుడు. What is first law? First law అంటే talks about inertia. It talks about inertia. అంటే ఏంటిరా? First law simply states an object in the rest is always in the rest. Similarly, an object in the motion is always in the motion. Adhe. Statement entira. Sir, very obvious statement, sir. Okay. Sir, these are all very obvious statements, sir. Yandugu so much of why are you doing too much makeup for these objects, sir? Huh? If this pen is at rest, it is going to remain at rest. So what is so special in it? Why it has to design as a law? Law, it's a very big thing. Understand? Are you understanding? And Newton is famous because of these laws only. Major factors of fame of Newton include laws, dan tarvata calculus. Chuskondi. What is so special in it? Object at rest is rest only. This is a pen, sir. It is remaining at rest only, sir. What is so special about it? Nothing special. Kani. Special is this ray. This is the special thing. Ante enti. Object in motion remains in motion. Ante enti. So if I am throwing this, let us say I am riding a bike, bike, okay? You give the speed, bike is in motion, So according to Newton, it should be in the motion only. Why is it stopping? Understand me? Why is it stopping? So an object at rest must be at rest. Why is it stopping? Ante Newton visualize. If I throw this pen into space, space ante enti, where there is no force, no gravity, no friction, no tension, no spring force, nothing. If I leave this pen in gravity and I gently push it, hey, visualize, try to visualize, okay? Try to visualize, I'm telling you. If I have this pen in space ante enti, away from all the planets, you go in space. So Newton imagined himself in a space. That time rockets were not there. 1600th century. 1600s of century. Until no electricity, no mobile phone, no rocket, no bike, no car, nothing. Understanding? Huh? In India, there are Mughals. They are fighting with one another. Our time low, he imagined himself in space. Understanding? That is the greatness. So he imagined himself in a space and he is telling, if I go in space and if I slightly pinch this pen will keep on moving forever. It will never stop. Understanding? It is just moving, just moving. It is the first law of Newton. An object in motion always remains in motion. But it is only valid until and unless. Terms chuskondi, okay? And unbalanced external force acts on it. If an unbalanced force is acting, external and unbalanced, both are important, okay? Both terms are important. Chuskondi. You imagine a scenario, okay? I'll tell you. Imagine chuskondi. So you are sitting in this bus. Some 10-15 members are there with you. Okay? Some 10-15 members are there. All of them that decided, let us go to one end of this bus. Okay? All of them, they are going at one end of this bus and they are pushing the bus. Will it move? Will it move? If you push the bus from inside, all of you collect one place, 30-40 members in a bus, you push that bus inside, from inside. Will it move? Will it move? Yes, it will move. It will move. So, if all the people, they come at one place and they are trying to push a bus, will it move? No. Good. It will not move. So we need Balaya for that. Okay? We need. So the bus will not move. It is internal force. Internal force keeps no significance. Yes, not outside, only inside the bus. So if the people are pushing inside the bus, they'll not be able to move the bus. Similarly, you hold your here and try to pull up yourself, right? Is it possible that you'll pull yourself up? No, you can't. Similarly, you can't push yourself, right? You can't push yourself. Do whatever you want, you cannot push yourself. Okay, you cannot push yourself. Understanding endukante all these are internal forces ra. Okay, internal forces. To change the state of an object, an unbalanced external force is required. Simple explanation ra. Okay, simple explanation ante enti ra? No, darken. ఏదైనా చేయండి, it will not move ray from inside. If you are calling Spider-Man, okay, if you are calling Bahubali also, if you are calling Superman also, you tell them, hey Spider-Man, kick this bus. The bus will not move. Even if you are kicking it with the highest power, the bus will not move. Ante kada? Are you understanding? Good. Even if you jump, you punch, you kick, even if you are kicking with the highest power, the bus will not move. Okay, yes. Endukante it's an internal force. So whoever is there, you call Bahubali, you call whoever you call it, this bus will not move. Ante kada? Why? Because it's an internal force. Okay, finished. Similarly, you can't lift yourself, you can't lift yourself, you can't push yourself, you can't pull yourself, you can't do anything by yourself. You need external agents. Ade simplification of Newton's first law ante enti ra? Rest to motion లేదా motion to rest. అండర్స్టాండింగ్? ఈ మొత్తం చేయడానికి you need an unbalanced external force. అదే unbalanced ఎందుకు సార్? Unbalanced ఎందుకు? Even if it's external and it's balanced, it will not move. చూసుకోండి, this block was at rest, 10 kg block was at rest ra. Okay, an external force of 100 Newton is acting, కానీ at the same time here also 100 Newton is acting. Balanced forces kada, no motion. Unbalanced external force must be there. So we need unbalanced external force. Then to move from rest to motion, లేదా motion to rest, you need an unbalanced external force. This is the only law of Newton's. Okay, first law antera. అయిపోయింది. Okay, done. Next. Hey, I have to discuss few more things also. Inertia ante enti ra? Inertia ante enti? Chuskondi. Inertia ante enti? You imagine something like this. Okay, inertia is hunger. Okay, I'll give you an example, right? I will try to explain you with a very easy example. Andarki chuskondi. Be with me ra. Inertia is what? What is inertia? You imagine oka house lo there are some five people are there. Okay, 5 people are there. Chusko. So this is the house. Okay, this house. This is the house. I used to draw houses, right? Not able to draw it properly. Chusko. So it is the house, right? And there are some 5 people sitting in this house. Okay, 1, 2, 3, 4, 5. Every person eats 1 kg of chicken. Understand. Okay. Yes. Ritik, that's the definition. The natural tendency of a body to resist the change of the motion is inertia. Kani nagu em artham raledura. All that you said went off my head. I am trying to explain inertia with an example. Okay, I am trying to explain inertia with the help of an example. I am telling you that same example. Chuskondi. There are 5 people in the house. Each person needs 1 kg chicken to fill the stomach. Okay, eat fully. 1 kg of chicken is required. Okay, 1 kg of chicken is required. So let us say some person gave 5 kg of chicken. Okay, some person gave 5 kg of chicken. All of them, they are happy. ఎందుకంటే 1 kg chicken, I'm completely full, I'm happy now. ఇప్పుడు the same thing, there are 10 people in this house, same house. ఎందుకంటే these 3 brothers got married. Okay, 6 plus 2 8, and 2 of them got one children. So imagine ide house lo now there are 10 members ra. Chappu. Do you think all 10 will be happy only by this 5 kg chicken? No, they will not. They will not. They will not be happy. And one day, members increased, hunger increased, food increased. Members increased, hunger increased, food increased. Ade, understand this process. So, deentlo inertia ante happiness. Okay? You imagine inertia as the happiness. So, initially, when 5 kg chicken was there, all were happy ra. Kani, when there are 10 members, no one is happy. Person increased, hunger increased, food increased. Ante kada, same thing. Chusko here. 10 kg of block ra. Okay, and 10 members in this house. Okay, each member requires 1 Newton force to be happy. Understand? Something like this. Each member out of this 10 requires 1 Newton force to get happy. Ante, if you are applying 10 Newton force, the acceleration is 1 meter per second square. Ante happy. Understanding? Increase mass. So ఇప్పుడు I am telling, let us say, instead of this 10 kg, I have this much kg of mass is there. Understanding? How much mass? 100 lakhs. Too much. 10 lakhs. Okay, 10 lakh Newton. 10 lakh kg of force is there. Okay, na degra 10 lakh kg of force is there. Eppudu cheppu. Same force I am applying, 10 Newton. What is the acceleration? Sir, acceleration is equals to 0. Hey, you understand it, okay? How many zeros are there? 1, 2, 3, 4, 5, 6. 6 under 10 over 6 under 5. 1, 2, 3, 4, 5. Right, correct. Okay? So this is the acceleration. Hemandira. Mass increased. Hunger increased. More food required. Can you are providing same food at 10 only? Understanding? Inertia is the property. So this is happy. And 1 meter per second square. I want to keep this also happy rate. So for acceleration is equals to 1 meter per second square. More food is required. Kada? More food ante how much rate? F is equals to Newton. Other. So members increased, hunger increased, food increased. This is inertia. Ante inertia is what? You give 10 Newton to 10 kg, more motion is there. More motion ante maximum acceleration 1 meter per second square. Increase mass, acceleration decreases. This is the property. Ante more particles are there. Each particle will eat some force. Understanding that hunger is known as inertia. I hope you are able to understand it. Okay, next. Right. గుర్తుందా రే ఇనర్షియల్ ఫ్రేమ్ ఆఫ్ రెఫరెన్స్ అంటే ఏంటిరా? ఇనర్షియల్ ఫ్రేమ్ ఆఫ్ రెఫరెన్స్ అంటే ఏంటి సార్? ఇనర్షియల్ ఫ్రేమ్ ఆఫ్ రెఫరెన్స్ అంటే the frame of reference that is not moving at rest or constant velocity, rest or constant speed. Ante kada? Yes. Ante it is at rest leda constant speed ra. Okay. So this is the room, sir. Imagine cheskondi ra, idi na room. Ee room lo oka table untundi ra. So this is my table, okay? And this is my chair. So idi na chair ra. This is me simply sitting, okay? This is me simply sitting into the room. Understanding? Good. So ide and here is a chicken. Why are you talking about chicken, sir? Not chicken, right? Let us do one thing. It's a book, Ray. Okay, it's a book. Physics book, okay? Physics book. So I'm just sitting in the room staring at that book only, Ray. Okay, I'm chitty now. Scan the books, automatically everything is there in my mind. Okay? So this is me sitting on the chair looking at the book only, staring at the book only, and suddenly this book is jumping up. something like, okay, jumping ray. This book is jumping. What should I understand ray? Let us say here is the clock and the time is 12 at night. 12 at night and 12 a.m. ante kada? Yes. 12 a.m. time is there. Nobody is at house. Okay, and there is this graveyard behind my house ray. Okay, this is my graveyard. Cheppu. Idena graveyard. Okay, and here is the hospital. Hospital ante morgue. Morgue. Okay, hospital morgue is there. Chep. So I'm staring at that physics book and it is bouncing. Thop, 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 thop. Yeah, absolutely. Tobio will solve it. Okay, we'll solve it. No problem. So, what will you say? Dayamundira, Dayamundi. Sir, someone is there in my room, sir. He is taking the book and he is making the book jump, sir. I don't know who is it. The first thing that you will do is run. As fast as possible, run from that place. Ante kada? Why is it happening? So, immediately next day, Newton is coming to your house and Newton is saying, hey, idiot, you don't understand physics only. Huh? You are idiot or what? What should I say now? Chappu. What should I say now? What should I say now, Ray? So, Newton is telling, your frame of reference was inertial frame of reference, Ray. And in inertial frame of reference, my rules are valid. Kani, it is your mistake. It is not inertial frame of reference. Ade, that's what I told you. All laws of Newton are only valid in inertial frame of reference. Understanding, if you want to apply Newton's laws in non-inertial, something like this happens, Ray. So, dayam, you'll run it. Understanding. So, if you want to understand all three laws, you must need inertial frame of reference. Yeah, exactly. If you are not into inertial frame of reference, then you will say, sir, someone is there. Shh. Someone is there, sir. Sir, I saw some two eyes. A big smile, sir. I saw it. Then the stories will come ahead. That student somewhere, he saw Dayamanta and he is having supernatural activities. Why is it happening? Why? Because you did not understand physics. In physics, Newton's laws of motion. See, the first thing, hey, you understand it, okay, what I'm telling you. See, even if you hate Newton's first law, you love it in your mind. Endukante, you are expecting, chusko. If this is a bottle, Ray, hey, if this is a bottle, okay, can you visualize it is a chair, Ray, okay? This is the chair, how should I tell you, Ray? Okay, so this is the bottle. Imagine, Ray. So if I'm telling you this is a bottle, you are expecting this bottle to stay here only. Understanding? And the object at rest should remain at rest only in your mind. What will happen if the bottle is jumping, sir? Sir, Dayam is there, sir, we will run. Understanding? Okay. Yes. So you will say, sir, there is this coast and we will run. Newton's first law is breaking. It's breaking. So that is why inertial and non-inertial frame of reference come into the scenario. Chuskondi. Now what happened is you did not sit in your room, you sit in a lift. Lift ante telusa. Lift ante the lift is moving down. Chuskondi. The lift is moving down with some acceleration A. Same experiment ra. Ide na table, okay? Ide na chair ra. And it is me sitting, Ray. Okay? This is me sitting. This book is there. And suddenly lift is moving down and this book is shifting up. How will I explain you? Here, Ray, here. Chuskondi. Hey, chuskora. So this is my lift. Okay? Right. Hey, this is my lift and this is my book. Chuskondi. Okay, all of you visualize it. Okay? Visualize it, Ray. So, according to you, this remote should stay at rest only, kada? But see, what's happening? I think you'd not be able to see it, okay? Understand. Hey, it was in the air, Ray. Hey, it was in the air, Ray. How did it move? Choose count. Because our frame of reference is moving. Okay. So in lift low, you will automatically see that this book is going up. Will you tell that same story, Ra? Huh? Everything will move. Okay, if the lift is going down, you will also move, book will also move. How, right? Because point number 1, to understand. This book moved, you observe. Yes, sir, this book is moved. Ante, ever move chesaru? Who applied the force on this book? Nobody. Is there anyone other than you in this lift? Nobody. Then how did it jump? Because you are understanding Newton's law in a wrong frame of reference. Okay. Good. So to understand Newton's laws of motion, meeku inertial frame kavalira. Non-inertial frame of reference unte some extraordinary, okay, some what should I say? Paranormal activities you will be observing. Okay, don't call, sir, it's a ghost, run away. No, it's physics. It's a physics, okay. So Newton observed this scenario, ra. So Newton said, hey, nobody is there, okay. So idena lift, okay, idena lift unte, a lift lo oka book pettandi, book ante block, whatever, you put it a block of mass m, and suddenly this lift is moving in the downward direction with an acceleration a. Here we are setting a camera, ra. Okay, it's a camera, chuskondi. So camera will record a footage. Automatically this mass moved up. Ante lift lo dayam undira. Lift is gone. Okay, everybody is running. They did not understand it. So Newton imagined, same thing, chuskondi. Newton imagined, at such scenarios, there will be, to correct, okay, problem is there, right? Problem is there. To adjust this thing, to adjust this gap, we introduce some concept. Em concept, ra? Concept of pseudo force. Chuskondi. What, re? Pseudo force. Pseudo ante enti, ra? Pseudo ante enti? Pseudo ante fake. Pseudo ante fake. So to break this gap, ante nobody was there in the lift, but camera is showing the block is moving up. Ante dayam is there. Okay. So in your language, you call this pseudo force as dayam. Ghost force. Okay. Ghost force. So when does it act, re? Always acts when your frame is non-inertial frame of reference. Ante kada. Point number 1. Point number 2 about this pseudo force, ra. The direction of pseudo force is always opposite to the direction of motion of frame of reference. Chuskondi. These are very important rules, huh? Yes, good. So very important rules. Point number 1. What is point number 1? Pseudo force will only act when your frame is non-inertial. Ante, if your frame is moving with some acceleration, lift, room, whatever it's there, okay? Understanding? Good. Okay? So, pseudo force gurinchi maatladutunna, chuskondi andariki. Pseudo force. Number 1, acts when frame of reference is non-inertial. Hey, good petkondira. Okay. Point number 2. Direction of pseudo force, ra. Hey, direction of pseudo force. Pseudo force ante fake force, ra. Okay, it's not there in real. Nobody is there, kada, but still moving. Ante we are adjusting. There is a force. Because without force, no motion is possible. So Newton said it's there, but you call it as pseudo force. Okay, good. Direction of pseudo force is opposite. Hey, chala important, ra. Okay, I'm highlighting here. Chusko is opposite to the motion of frame of reference. Ante entira, you imagine this, okay? You imagine this. So, ide na track. On this track, I am putting a block of mass m, ra, and suddenly this track is started moving with an acceleration a. What happens, ra? Emaitadi cheppu andariki. If I am putting a block and suddenly moving in the forward direction, what will happen, Ra? I don't have any proper tools of experiment to show you. Kani, you understand it, okay? I'll try to make you understand. Hey, choose Kondira. Can you visualize? Not, you can't visualize. You can't visualize, okay? You can't visualize. Let's take a bottle now. Hey, visualize it. This is same bottle only, okay? This is the bottle, okay? This is the bottle, Ra. Choose ko. Choose ko. It is at rest. It is at rest. Kani, what I'm doing now is, so see. I should place here, Ra. Okay, I should place it here. All of you observe it, okay? All of you observe it. Yes, it's moving in the backward. Why, Ray? Why? If you move the block in the forward, the bottle is moving in the backward direction. I've gone, right? Not gone. Okay, I'm breaking the bottles to make you explain the things. Ante kada. Understand, Cheppo. Why is it moving backward, Ra? Good. So if the frame is moving in one direction, pseudo force will be in the opposite direction. Understanding pseudo force. Cheppora here in this scenario. Andarki cheppandi. Okay, tell me, all of you tell me. So, lift, moving up, cheppo. Acceleration. Direction of pseudo force, Ra. Cheppandi andariki. Pseudo force ki direction on this block. Point number 3. Point number 3 in this system only. Choose Kondira. Okay, point number 3, I'm writing here. You understand point number 3, okay? Dan tarvata we'll move. Point number 3 enti Ra? Pseudo force never acts on system, Ra. Okay? Never acts on frame of reference. But always acts on the objects which are not attached in it. Ade. Ante, choosukondira. So here, there will be no pseudo force on the trolley, Ra. Hey, on this bike, no pseudo force. No pseudo force on car, Ra. Okay? No pseudo force on car. Kani, there will be pseudo force object placed inside it, kada? In it. So it is my object. So the pseudo force will be acting on this mass. Ekkada kuda cheppandi. Here. Lift is moving down ante no pseudo force for the lift, Ra. Understanding? No pseudo force for lift. Kani, there will be a pseudo force on the block. Direction cheppura. On the block, there will be pseudo force in the upper direction. Opposite kada? Down, up. Here. Tell me, all of you. If the lift is going up now, with an acceleration A, cheppo. Good. So no pseudo force on lift. Kani, there will be pseudo force on this block. And the direction will be downward direction pseudo force. Ante kada? Yes, so this is all about the analogy, Ra. Ippudu values gurinchi chuddam. Andariki cheppandi. So now let us talk about the values. Pseudo force ki values kada. You imagine, Ray, okay? You imagine this is your bus. Let us see how many of you can give the proper answer, okay? Let us see how many of you can give the proper answer, Ra. It is a bus, Ray. This bus ki mass capital M is equals to 500 kg. Andariki. The mass of this bus is 500 kg. Ante kada? Okay, sir. And there is one more block. Placed mass is 10 kg. Ra. Andariki chuskondi. Okay. And there is this force acting on the bus. F is equals to 1000 Newton. Andariki. Tell me pseudo force on 10 kg block. How much re? Inta? D 2 Newton. D 2 Newton. 2 Newton is the new option that I got. Okay, 2 Newton. D. C. Okay, మొత్తం gone. All gone. Okay, all gone. Why? Because of a line. ఏం లైన్ రా? You don't know one information that I know. మీ దగ్గర ఒక్క ఇన్ఫర్మేషన్ లేదు రా, but I have it. That's why you are telling wrong answers. Okay. Why? I'll tell you that line. Okay, దాని తర్వాత you try to imagine. Okay, what is the statement that you don't have that I have? That is why you are not able to say the answer to this. Statement is this. చూసుకోండి, 5 marks, 5 star statement రా, 5 star statement. అంటే ఏంటిరా? Sir, you are applying 1000 Newton. So there should also be 1000 Newton. No. Pseudo force is not equal. Pseudo force is not equal to the external force. Okay? Not equal to external force. To external acceleration. Ante entira? Sir, pseudo acceleration is same. Ante force is 1000 kada? Mass 500. So acceleration entara? Ee block గురించి మాట్లాడుతున్నా. You can imagine, you can ignore this 10 kg block. Okay, don't consider the 10 kg block as a part of it. చెప్పు. Sir, acceleration is equals to 2 meters per second squared. Direction, right side. Hey, acceleration of bus, right side, 2 meter per second square. Acceleration is same to pseudo acceleration. Ante on this block there will be same pseudo acceleration of 2 meter per second square in the left. Mass 10, acceleration 2. Cheppora. Force is 20 Newton. Ante kada? Good, Ritik, very good. Okay. Always remember, pseudo forces are not equal. Pseudo acceleration is equal to magnitude. Okay, I'm talking about magnitude, not the direction. Direction is opposite. Okay. So చూసుకోండి. Pseudo acceleration ante enti? Pseudo, it is always equal in magnitude to the external acceleration. But direction is opposite to external acceleration. చెప్పండి. Now I'll ask you a question, Ra. తొందరగా చెప్పు అందరికి. So this is my trolley. Mass is capital M is equals to 100 kg, Ra. And on this trolley, oka block is there. Mass is equals to 5 kg, Ra. I'm applying a force. I'm applying a force on the trolley. F is equals to 200 Newton. చెప్పండి pseudo force on 5 kg block. Do it very quick. Okay, very quick. Hey, what you are doing, Ray? Hey. I'm blocking the vision. Again, I'm blocking the vision. Cheppu. Accelerations are equal, okay? Always remember, accelerations are equal. I want correct answers only, right? Okay? No, go not. 50 is wrong. 40 is wrong. Hey, acceleration calculate chira. Acceleration of trolley entare force by mass. What is force? What is mass? Acceleration. F is equals to m into a. Again cheppu andariki. I. Good. Darken. Very good. Very good. Pseudo forces. And what about pseudo acceleration? Darken. 5. How re? Hey, choose Kora. 200 force, 100 mass. Acceleration of bus is equals to force upon mass kada. Yes. Ante 2 meter per second squared. Ade. Now, external acceleration is 2 meter per second square, right low. Pseudo acceleration will be 2 meter per second square in the left. You have pseudo acceleration, you have mass ra, cheppo. Sir, F is equals to M into A. Pseudo kada, yes. Pseudo force is equals to pseudo acceleration into mass ra. Ante mass is 5, pseudo acceleration is 2, and 10 Newton of force is there in the left side. Understanding, not understanding, right? Good. Very good. Next రా తీసుకోండి అందరికి. This is my lift, okay? Hey, ఇదేనా లిఫ్ట్ రా. లిఫ్ట్ కి టోటల్ మాస్ క్యాపిటల్ M is equals to 1000 kgs, okay? 1000 kgs. మరి ఒక ఫోర్స్ ఆఫ్ F is equals to 20,000 Newton is acting on this lift ra. Find the pseudo force, magnitude and direction. చెప్పండి అందరికి. I'll be back in 5 minutes, okay? I will be back in 5 minutes. Getting it? Not getting it, ra? 200. Yes. 20,000, 20. Yes, very good. Direction enti ra? Darken, direction. What is the direction darken? Good. Very good. Gitanjali, very good. Very good. Okay. So ikkada nunchi you calculate the acceleration of the lift, ra, is equals to force by mass kada. Yes, so directly you can say 20,000 divided by 1,000 ra. Hey, ante 20 meter per second square. Oh, this is my acceleration, sir. What is same? Acceleration magnitude. And direction is opposite kada. Yes. So pseudo acceleration, it is also equals to 20 meter per second square. Kani lift acceleration is in the upward direction. Pseudo acceleration will be in the downward direction. Ante kada? Yes. Okasari you have pseudo acceleration, you have mass, multiply cheskodi, force vastundi. Okay? Good. So sir, pseudo force is equals to mass into pseudo acceleration. Ante kada? Direction enti ra? Downward direction. Ade. Okay? Right. Hey, చూసుకోండి రా. In this scenario, I did not give you the acceleration of lift. So we had to do it. Not 300. Not 300. Okay. So, what am I telling? You don't go for this approach. Okay. You just understand what I'm telling from the scratch itself. Ade. Pseudo acceleration is equal to the acceleration of the external system, frame of reference. Ante kada? Right. So, ee question lo na daggara acceleration of lift was not there initially. I had to calculate it. Dan tarvata I got it. Ante kada? So, acceleration of lift was 20 meter per second square. Here, I will directly give you the acceleration. I am directly giving you the acceleration. So, let us say acceleration is equals to 10 meter per second square. Ra. Chappu. Here is this mass. Entara 20 kgs. Question is find pseudo force on the object. Cheppu andariki. Pseudo force gurinchi cheppandi ra. Sir, direct acceleration untundi kada? Yes. So that means pseudo acceleration is same as external acceleration. Always remember the statement. That's why I told you. You take my lectures very seriously, Ray. I don't do time pass telling you all these nonsense things, okay? So pseudo acceleration is always equal to the external acceleration. Na daggara already untundi ra acceleration, external acceleration ki value. So that means the pseudo acceleration is also 10. Kani external acceleration paina gira. So pseudo acceleration kindaki act chestunnadu. Ante kada? Yes. So the pseudo acceleration is equals to how much? 10 meter per second square. Ade 10 meter per second square. Get. What about pseudo force now? Cheppu andariki. Pseudo force gurinchi cheppandi ra. Sir, pseudo force is equals to ade formula. Mass into pseudo acceleration ra. Ante kada? Yes. Mass ante 20 kgs ra. Pseudo acceleration is 10 ante 200 Newton pseudo force is acting ra. Direction enti ra? Downward. So ide na pseudo force ki direction ra. Ante kada? Yes. Good. Downwards. Very good. Eppudu we'll talk about a normal reaction ra. Okay. నార్మల్ రియాక్షన్ గుర్తుందా? జస్ట్ నౌ ఇప్పుడు డిస్కస్ చేశాను కదా. ఎస్, చూసుకోండిరా. సో ఇఫ్ దిస్ ఈజ్ యువర్ లిఫ్ట్, ఓకే, సో దిస్ ఇస్ అ బ్లాక్ రే, 10 kg బ్లాక్ ఇస్ దేర్ రా. చూసుకోండి అందరికి. lift is moving upward with an acceleration of 5 meter per second square. మొదటిగా you calculate pseudo force. Normal reaction calculate చేయడానికి pseudo force కావాలిరా. Okay, do you have pseudo force? You don't have. Calculate that. First, calculate pseudo force. దాని తర్వాత move to the normal reaction రా. Yes. So sir, initially నాకు pseudo force కావాలి sir. Pseudo force is equals to mass into pseudo acceleration. అదే కదా? Yes. Pseudo acceleration ఎంత రా? 5. Same acceleration is same రా. Mass is 10 into acceleration is 5 అంటే 50 Newton of pseudo force. Direction ఏంటిరా? External acceleration upward. Pseudo force downward. కిందకి. అదే. Understanding? Now come to normal reaction part రా. చూసుకోండి. Sir, its own mg. Hey. We did not discuss anything about mg of this block till now. అంతే కదా? Yes, we did not discuss. ఇప్పుడు I am going to discuss it. చూసుకోండి. Sir, mg అంటే 100 Newton. What is 100 ra? mg of this block. అదే కదా? Okay. Sir, in addition to this mg force, pseudo force is there. ఎంత రా? 50. Good. So sir, pseudo force is also there. F pseudo is equals to 50. అంటే total కిందకి force ఎంత రా? Total downward force is equals to 150. అదే కదా? Yes. Now, this total force will be balanced by the ground of the lift ra. So అంటే normal reaction by the lift is equals to 150. అంతే కదా? చూసుకోండి అందరికి. Are you understanding this? Yeah. Good. Very good. Good. Next scenario. So let us do one thing now. Okay. Let us take general values ra. So ఇప్పుడు I am giving you variables ra. చూసుకోండి. So ఇదే mass m. Lift is moving up with an acceleration of a0. Okay. a0. చెప్పు. Question is normal reaction by the lift. చాలా ఇంపార్టెంట్. చాలా ఇంపార్టెంట్. చూసుకోండి. Normal reaction by the lift. చెప్పండి అందరికి. So a0 acceleration. పైనకి pseudo acceleration same. Sir, pseudo acceleration a0 కానీ కింద యాక్ట్ చేస్తున్నారు. What about pseudo force? Sir, pseudo force is equals to mass into pseudo acceleration. అంతే కదా? Yes. Mass ఎంత రా? Mass is m only రా. What is acceleration? Pseudo acceleration a0 రా. So m into a0 in the downward direction. అంతే కదా? Yes. So that is pseudo force in the downward direction రా. కానీ ఇప్పుడు it's mg గురించి చూద్దాం రా. Sir, mg is also acting in the downward direction. అంతే కదా? Yes. So total force ఎంత రా? mg కూడా and pseudo force కూడా. Two forces are there. So sir, total force in the downward direction is equals to చెప్పండి అందరికి. mg in the downward direction plus ma0 అంటే ఇది నా pseudo force కదా? Yes, it is my pseudo force రా. In the downward direction. Add m కామన్ తీసుకోండి. m into in bracket g plus a0. It is my total force in the downward direction. అందరికి అర్థం చేసుకోండి. So if it is my total force in the downward direction, what will be the normal reaction rate? Equal to this only. ఎందుకంటే the block is standing on the surface kada, on the ground, on the floor of this lift. So the normal reaction by the lift will also be equals to m into g plus a0. You remember this as a formula. It's chala important formula. You always remember. I'm telling you, okay? I'm telling you. Total downward force is m into g plus a0. Ippudu re, when the lift is moving upwards. Kani downward veltundi. So let us take this case re. So in this scenario, lift is moving in the downward direction ra, with the same acceleration a0. Cheppu andariki, cheppu. So sir, mass m is there. Acceleration of the lift a0 unte pseudo acceleration ఎంత రా? Sir, pseudo acceleration is also a0. అంతే కదా? Yes. కానీ డైరెక్షన్ చెప్పురా. Upwards. Opposite. Yes. Sir, pseudo acceleration a0 mass m అంటే pseudo force ఎంత sir? Force is equals to mass into acceleration. అదే కదా? Mass into pseudo acceleration. అంటే mass into a0 in the upward direction. అంతే. ఓకే. సో ఇట్ ఈజ్ యువర్ సూడో ఫోర్స్ రే. అంటే ఇప్పుడు గ్రావిటీ గురించి మాట చూద్దాం రా. చెప్పు అందరికి. సో గ్రావిటీ ఈజ్ యాక్టింగ్ డౌన్వర్డ్. అంటే హౌ మచ్ రే? m into g. ఆల్వేస్ రిమెంబర్ m into g. కానీ సూడో ఫోర్స్ ఈజ్ యాక్టింగ్ ఇన్ ద అప్వర్డ్ డైరెక్షన్ m into a0. అండర్స్టాండింగ్. యూ ఇమాజిన్ సంథింగ్ లైక్ దిస్ రే. M into G is, for example, you say 100. For example, it is also, let us say 20. For example, opposite directions kada. How will you take the resultant force rate? Direct subtract. Opposite directions ra. Opposite directions. Ante, you will simply say, sir, net force is equals to చెప్పండి 100 minus 20 అంటే mg minus ma0 అంతే కదా. yes, so that means m కామన్ తీసుకోండి, g minus a0, so it is my net force. నాకు తెలియదురా this force is in the downward or upward, ఎందుకంటే if mg is greater the force will be downwards, if ma0 is greater the force will be in the upward direction, అంతే కదా. yes, so normal reaction చెప్పండి అందరికి. so normal reaction is equals to m into net force g minus a0. so what is the conclusion, sir? Conclusion is only this, చూసుకోండి అందరికి. so this is your lift, right? these are the two instances, చూసుకోండి అందరికి. first case లో lift is moving in the upward direction with an acceleration a0. second case లో lift is moving downward with an acceleration of a0, అంతే కదా. ఒక మాస్ m ఉంటుంది, it is placed on the ground of the lift. చెప్పండి net normal reaction రా. normal reaction by lift is equals to, directly చెప్పండి, if it is moving up అంటే pseudo force down, gravity down, addition m into addition g plus a0, అంతే కదా. here also moving down, pseudo force up, gravity down, subtraction అంటే నార్మల్ రియాక్షన్ ఇస్ ఈక్వల్స్ టు m into g minus a0. చూసుకోండి రే. hey, why does this keep significance అంటే if you have a weighting machine, hey, చూసుకోండి రే. hey, normal reaction is nothing but I'm writing a very big statement over here రా. చూసుకోండి, I'm writing a very big statement over here. normal reaction by lift is also known as very important, very important. okay, normal reaction anna apparent weight anna both are same. so if instead of this block oka person unte they can talk about the apparent weight. understanding gurtupettukondi, apparent weight is always equal to the normal reaction by the ground. so what type of questions could be asked today? చూసుకోండి, a block of mass 10 kg is attached to the ceiling of elevator moving with acceleration of 5 meter per second square. Tension in the string is how much? Calculate చేసుకోండి. సో ఇదే నా లిఫ్ట్ రా. లిఫ్ట్ అంటే ఎలివేటర్, ఓకే. అండ్ a block of mass 10 kg is attached. Lift is moving with an acceleration of 5 meters per second squared. చెప్పు, టెన్షన్ ఇన్ ద స్ట్రింగ్ ఎంత రా? సేమ్ ప్రాసెస్. యాక్సిలరేషన్ నుంచి సూడో యాక్సిలరేషన్ పై వచ్చింది, దాని తర్వాత సూడో ఫోర్స్ క్యాలిక్యులేట్ చేసుకో, అండ్ దాని తర్వాత సూడో ఫోర్స్ అంటే నెట్ ఫోర్స్ క్యాలిక్యులేట్ చేసుకోరా. ఇన్స్టెడ్ ఆఫ్ గ్రావిటీ అండ్ ద సూడో ఫోర్స్ రిజల్టెంట్ ఫోర్స్ దాట్ వుడ్ బి ఈక్వల్ టు టెన్షన్ ఫోర్స్. చెప్పండి అందరికి. 50 Newton acceleration. Pseudo force is 50 Newton or acceleration is 50 Newton. I want tension. Tension is not 50 ray. Hey, direction ray. Direction చూసుకోండి రా అందరికి. Direction. Your direction is getting wrong ray. Acceleration of lift 5 meter per second square. Understood ra? What about acceleration? Pseudo. గుర్తుపెట్టుకోండి. What did I say? That's what I was telling to you. You remember all each and every of my slides. Okay, where did I start this chapter ra? Where did I start this chapter ra? అందరికి. Yeah. See, pseudo force never acts on the frame of reference, but always acts on the object which are in it. Ante, if this is the lift, pseudo force will never act on lift ra, but object inside it, ante block. Point number 1. Point number 2, direction of pseudo acceleration force will be opposite to the direction of external acceleration. Ante kada. So lift ki acceleration paina gi undi ra. So the block's pseudo acceleration will be in the downward direction. Ante kada. And pseudo forces are not same. Pseudo accelerations are same. Ante 5 here also pseudo acceleration is equals to 5 meter per second squared. చెప్పు నీ దగ్గర acceleration ఉంటుంది, calculate చేయండి, force రా, pseudo force is equals to mass into pseudo acceleration. అంతే కదా. mass ఎంత రా 10, pseudo acceleration ఎంత 5, అంటే 50 Newton is the pseudo force. ఏం force రా? pseudo force. This is not equal to tension ఎందుకంటే its own gravity is also acting రే. You are forgetting that points రా. Gravity అంటే 100 Newton కదా, mg రా, mg plus this 50 Newton. Total force in the downward direction is 150 రా. దాని తర్వాత you say tension force is equals to 150 also. Okay, good. So tension is equals to 150 Newton. అందరికి చూసుకోండి. Don't ignore any of the forces. This is the biggest problem that each and every student faces రా. What's the problem? They are ignoring the forces. Ante here gravity was not mentioned, so you skipped it. Good. Great. Next. Okay, in the previous problem, what if the lift is going with the same acceleration but downwards ra? ఇదే problem లో lift కిందకి వెళ్తే what will be the tension? చెప్పండి. mass is how much? 10 kgs కదా. yes, కానీ lift is moving in the downward direction with an acceleration of 5 meter per second squared. Let us see how many of you can answer. Good. Gonad, good. Good, great. Darken, very good. So, ఎలా calculate చేస్తున్నాం సార్? Acceleration of lift is down, అంటే pseudo acceleration of this block will be upwards. ఎంతరా? Same. Pseudo acceleration is equals to 5. Mass 5, mass 10, acceleration 5 అంటే pseudo force is equals to 50 Newton in the upward direction. ante kada. yes. What about the gravity ray? Gravity is acting in the downward direction. mg is equals to 100 ra. Net force గురించి చెప్పండి అందరికి. Net force sir, net force is equals to 100 minus 50. 100 ఏంటి రా? 100 అంటే gravitational force, 50 అంటే pseudo force. అదే కదా. yes. so sir, net force is equals to 50 Newton. ఇక్కడ నుంచి this net force direction is in the downwards. ఎందుకంటే mg is greater. చూసుకోండి, mg is greater, so net force is downward. సో ఈ ఫోర్స్ ని బ్యాలెన్స్ చేయడానికి టెన్షన్ షుడ్ బి అప్వర్డ్స్ అండ్ టెన్షన్ వాల్యూ షుడ్ బి ఈక్వల్స్ టు నెట్ ఫోర్స్ వాల్యూ రా in the upward direction. Okay, can I add one more point in this question? ఈ question లో I'll add one more point. Okay, you try to do it. Okay, question is what should be the value of acceleration ra? Hey, what should be the value of acceleration of lift such that tension in the string becomes 0 ra. Cheppandi andariki. Initially when the lift was not moving, tension was 100 kada. The lift is moving, tension becomes 50 and decreased. So what should be the value of acceleration so that tension becomes 0? Ade. Good. Hey, let us imagine here, same question I'm drawing here. Chuskondi. Tension will only become 0 when the lift is moving down. It is the only case. If the lift is moving up, tension can never become 0. Okay, it is just going to increase. Okay, good. Ritik, very good. So imagine chuskondi, ide na mass m ra. Let us say lift is moving with some acceleration a. Naku value teliyadu, kani I know the condition that for this a, tension is 0. Ante kada. Tension is 0 ante enti ra. So let's talk about forces on this block. Sir, modatiga the gravitational force is acting. Ante kada mg. If the acceleration of the lift is a, pseudo acceleration will also be equals to a. Ante kada. Yes. What about pseudo force ra? Pseudo force, sir. Pseudo force is equals to mass into acceleration ante m into a. So if tension has to become 0 ra, the pseudo force should balance this mg. Chuskondi. Why? Enduku sir? Because tension is balancing the downward force. Ante kada. Downward mg, tension also mg. Downward 100, tension 100. Downward 30, tension 30. Downward 0, tension also 0. Ante ee mottam mg force ni I have to balance this with this pseudo force. Ante kada. So sir, pseudo force should be equals to gravity. Pseudo force entara m into a. So gravitational force entara m into g. Ade kada. A gone re. A is equals to g. Ante if the lift is falling down with an acceleration equal to g, tension is gone. Tension is gone ante telusa. You wipe this string ra. There is no meaning for string. Endukante tension is 0 kada. Yes. So you remove this string itself. Ante the block is in the air re. Ante the block is not moving down also, not moving up also. It is known as free fall. Right? Right? This condition is known as masslessness, not free fall. Okay? Masslessness. Ante enti telusa? Ante if the object is moving down with the same acceleration as g, the person in it will feel weightless. Masslessness or weightlessness. Hey, not masslessness. Hey, not masslessness. Weightlessness. Okay. I did not focus, but it should be weightlessness. Chuskondi. Masslessness and weightlessness are different. Masslessness ante object is gone, disappeared. It is known as weightlessness. Okay. Yes. When does this happen? Right? Weightless. You have seen the videos. Sunita Williams. You have seen the video. International Space Station lo. They simply swim. They don't fall down. They simply swim. Okay? No gravity. Understanding? Some similar setup is there. Right? Good. Weightlessness condition. Remember it. Okay. Next. Two blocks of masses 50, 25 kg is connected to the ceiling of an elevator, moving up acceleration of g by 4 ra. Tensions in the each string ra. Cheppandi andariki. So now there are two blocks. See, I am taking from very elementary level and I am raising the level of the question to a deep level. Today now first block, mass 15 kg, immediately attached to one more string ra. Today now second block, mass 25 kg. Left moving up with an acceleration of g by 4 meter per second square. Cheppandi T1 value 8, T2 value 8. T1, T2. Am I audible, all of you? Am I audible? Because the mic fell down. త్వరగా. $490 T1. Okay, what about T2? Take value of G as 10, okay, not 9.8. I've already telling you in my class G value is always 10, not 9.8, okay? Okay, Gonat, T1 is 500 Newton. What about T2, right? What about T2 now? Cheppandi. So if the lift is going up with G by 4 ray, pseudo accelerations will be downwards kada. Yes, sir. Ekkada the acceleration pseudo is equals to G by 4. Ekkada kuda same scenario re. Hey, pseudo acceleration is equals to G by 4 ade kada. You always remember, if you have block system one upon another, start from top. Ade I told you earlier also. ఇక్కడ కూడా అదే చెప్తున్నాను, స్టార్ట్ ఫ్రమ్ టాప్ తోనే స్టార్ట్ చేసుకోండి అందరికి. గుడ్ గీతాంజలి, గుడ్. లెట్ us see. సో స్టార్ట్ ఫ్రమ్ టాప్ అంటే యు ఇమాజిన్ ద టోటల్ మాస్ హ్యాస్ వన్ సిస్టమ్ రా. టోటల్ మాస్ హ్యాస్ వన్ సిస్టమ్. ఓకే, సో సార్ 15 plus 25 అంటే 400 kg is the net mass of the system, అంతే కదా. ఎస్. సో ఈ 40 kg రా, 40 kg. సో ఈ 40 kg పై సార్ mg అంటే డౌన్వర్డ్ చూసుకోండి అందరికి. సూడో యాక్సిలరేషన్ ఇంతారా, g by 4 downwards. Here also g by 4. Sir, pseudo acceleration is g by 4 and g by 4. అంటే g by 4 plus g by 4 అంటే 2g by 4 అంటే g by 2 కదా. Yes. So pseudo acceleration is g by 4 for 15, g by 4 for 25 అంటే 2g divided by 4 అంటే g divided by 2 సార్, అంతే కదా. pseudo acceleration రా, pseudo acceleration is equals to g by 2. What about pseudo force, sir? Sir, pseudo force is equals to total mass multiplied by total acceleration. Total acceleration entara g by 2. Sir, total mass is 40, total acceleration is g by 2 అంటే 10 by 2 అంటే సార్ 40 into 5 అంటే 200. total force pseudo force is 200, అంతే కదా. సో pseudo force, sir, it is equals to 200 Newton of pseudo force. And sir, mg అంటే 40 into 10, 400 plus 200, sir. Sir, 400 plus 200 gives us 600. Tension in the string is 600, ante kada. This is wrong. Enduku wrong? Don't add the pseudo accelerations. Don't add them. Okay, don't add them. Basic concept, right? This is the concept. Hey. This is the concept. You don't add pseudo acceleration. When you are considering them, it is not additionable. So total acceleration is not g by 2 ra. Pseudo acceleration kuda g by 4 re. Hey, pseudo acceleration is common for all masses re. Why are you doing like this re? Pseudo acceleration is g by 4. Chusko andariki. Understanding? So ide na pseudo acceleration. Total mass on total masses ra. You don't add the accelerations. Andariki ardham cheskondi. Good. So pseudo acceleration is g by 4 ante pseudo force is equals to total mass into pseudo acceleration ra. Total mass is 40. Pseudo acceleration is 10 by 2. 10 by 4 ra. Okay, so it is equals to cheppu andariki 100 Newton. Ide na pseudo force in the downward direction ra. In the downward direction. So ide na pseudo force re. Yanta 100. mg enta ra 40 into 10 ante kada. So ante 400. Now the total force is 500. Kinda gira. Net force on the total system is 500. To balance this, T1 will also be equals to 500. Great. It's a very slight twist. Sometimes you're ignoring this fact. So random masses unte, you don't add their pseudo accelerations. It's a common acceleration with which both the masses are moving. Andariki ardham cheskondi. Okay? Good. Now, T2 kosam come to 25 kg block only ra. Cheppu. So 25 kg block ante mass into g, mg 250 in the downward direction. Pseudo acceleration g by 4 kada. Pseudo force cheppandi. Pseudo force on 25 kg. Okay, 25 గురించి మాట్లాడుతున్నారు చూసుకోండి. Is equals to mass into pseudo acceleration ra. Mass ఎంత 25. Pseudo acceleration 10 by 4 అంటే 250 divided by 4 అంటే 62.50. not 25. 62.50 అంతే కదా. 125 right. So ఇదే నా pseudo force ra. Pseudo force is 62.5 plus 250. So net force is equals to చెప్పండి అందరికి 62.5 plus 250 అంటే 312.5 Newton. ఇదే net force will act as tension T2 కి value. T2 is equals to 312.5. T1 is equals to 500. ఎవరికి చెప్పిన ఆన్సర్ చెప్పాడు. Hey, Srikar Reddy, hey, what are you talking? Hey, you should be here. I would have killed you, okay? I will have killed you. Hey, see my teeth. Do I look like a Vimal eater? That's why the people, they make me so angry. I want to kill you, okay? I want to kill you. Who is this? Yes, Srikar Reddy. I want to kill you. Okay? He is telling, sir, do I eat Vimal? And voice is good. Two different compliments in one scene, ra. Okay? What is looking like Vimal eater, re? My cheeks are in, my teeth are black. What, re? Okay, చూసుకోండి అందరికి. different people come from different places. Yeah, Banu, class will be there. Okay, my target is to start Newton's second law. Okay, దాని తర్వాత okay. Once we finish Newton's second law, it will be done. అంటే half an hour more. అదే. Okay, half an hour more. Okay. Next, spring weighing machine and in a moving lift. So, in the very same lift, we are going to put spring and weighing machine. Okay? Spring and weighing machine. చూసుకోండి. So spring గురించి మాట్లాడితే, so let us say it is my lift tray. Okay? So weighing machine in a lift. So this is my spring ra. చూసుకోండి. 10 kg block is there, right? 10 kg block. 10 kg block is there. Okay. Let us say this lift is moving up with an acceleration is equals to g meter per second square. G under 10. Okay. Don't confuse. In my lecture, g is 10. Okay. Okay. I don't like 9.8 value. I don't like 9.8. I like 10 only. Okay. కాబట్టి 10 తీసుకోండి. వాల్యూ ఆఫ్ g is 10 in my lecture. Okay, in my lecture ra. Chalo, k is equals to 100. Question is find elongation in spring. చెప్పండి. 0. Yeah, Spandana. But I don't like 9.8. Okay, it creates problems. Spandana, you like 9.8? You like 9.8? Hey, you take 9.8. Chappo. If I'm taking G is 10, Spandana, you are taking G as 9.8. Okay, Chappo, G square Chappo. Hey, 100 easily that. Tell me the square of 9.8. Okay. That's why I don't like 9.8. Okay, okay, okay. 1 meters. Chuddam. But you are again skipping the gravitational force of the object. Okay. For all who are saying 1 meters, you are skipping the weight of the object. Okay. Acceleration 10 ra. And a pseudo acceleration kuda 10 kada, same as external acceleration. Pseudo acceleration 10, cheppo, pseudo force entara mass into acceleration. And 10 into 10. And 100 ra. But there is gravity also, re. Hey, mg is there, re. Ante gravitational force cheppandi andariki 100, 200. Here is 200, here is kx. Ante kada? Yes. ये क्या बोल रही हो ऋतिक सर? कैसा आएगा 1.8 रा? हाँ? 1.8, which angle are you going with? No. So net force in the downward direction ra cheppani andariki. Force in the downward direction is equals to 200. And this should be equals to k into x ra. 200 is equals to 100 into x. X is equals to 2 meters. Ade you are ignoring the mass, okay? mg force. That's the biggest mistake that you can do. Understanding all of you? Okay. Next. Cheppandi andariki. Next scenario ra. Deentlo I'm putting a weighting machine, okay? These are only the formats in which the question have been asked. Kabatti I'm taking it, okay? No other reason. What trick? You have to remember it. You don't have any other option, okay? You have to remember it. Gravity is always acting. If you are skipping gravity, your marks will be skipped. And what trick? No trick, no. No trick, re baba. No trick. Okay, you can imagine like this, re. If the lift is moving up, ye enough force it is. Weighing machine, spring, string, whatever it is. If it is going up, m into g plus a. Okay, m into g plus a. If it is going up, for lift is going up, you take m into g plus a and equate it with the external force. Okay, if it is coming down, you equate it m into g minus a. This is the shortcut and sweetest trick. Here, choose here. Lift is going up kada, mass 10 into g plus a. G value is 10, a kuda 10 untundi kada. So 10 into 20 and 200. So this is my force. You equate it with the external force now. So external force is spring force. And k into x is equals to 200. And x is equals to 2 meters. Okay. Similarly, imagine I have a lift. Okay. This lift has a weighing machine. Okay. Weighing machine. Okay. What is weighing machine? Weighing machine will catch the normal reaction. You remember, weighing machine will always catch the normal reaction. And it will divide that normal reaction by the mass to give you the apparent mass. Hey, apparent weight teeskora. Cheppu. If this lift is coming down, with an acceleration is equals to 2 meter per second square. Cheppandi andariki. And if there is a person of mass 100 kg, what's your mass, Ray? Ritik, what is your mass? Talking about tan theta is equals to a by g. No. Not for now. Okay, not for now. We'll come on that formula, Ritik, but not for now. Okay. Cheppu andariki. Okay. Coming down kada, for down it is m into g minus a, directly substitute. So net force is equals to m into g minus a. Ade direct shortcut formula. M is 100 into g minus a is 10 minus 2, 8 ante 800. 800 Newton is the apparent mass of this person, not mass, weight. Apparent weight is 800. So this is the reading in your spring machine, but it does not show you 800. Endukante it will divide by 10, divide by g ra. So apparent mass is equals to 80 kg ra. Understanding? Apparent mass apparent is equals to this, and weight apparent is equals to that. I am not wasting much time into these problems. Okay, you make some questions. Hey, listen to me. Hey, listen to me, ra. Hey, you make some questions like this by yourself. Okay, you make some questions like this by yourself, and you try to solve them. If you're not getting the answers, ChatGPT, Google. Next, a pendulum bob. Oh. Okay. So now we'll take a case, ra. Before that, చూసుకోండి. I'm talking about effective acceleration, okay? Effective acceleration. Effective acceleration ante entira? If the lift is moving up, if the lift is moving down, చూసుకోండి అందరికి తొందరగా. We will try to cover it as soon as possible, ra. It is moving up with an acceleration a. There is some pendulum, not pendulum. I don't like it. Let us say mass m is there, ra. Cheppandi andariki. If it is moving up with an acceleration a, pseudo acceleration entara? Pseudo acceleration is equals to a. What is its own acceleration due to gravity, ra? Acceleration due to gravity is equals to g. Ade kada? Yes. Rendu accelerations in same direction ante net acceleration is equals to g plus a. Ade, hey, remember this formula, okay? G plus a. Net force ante mass into g plus a. Ekkada vachi? Same thing. Mass m is there. Lift is moving down. Acceleration a. Pseudo acceleration is equals to a. Kani acceleration due to gravity is g in the downward direction, ra. Cheppu. Net acceleration is equals to g minus a. Endukante opposite directions kada? Right. So this is my net acceleration. Good. Good. Dark and very good. Okay. Next, so if the acceleration is in the horizontal, in case what is the net acceleration? Chuddamam. Okay. After that, next. Okay, next. So if the acceleration is in the horizontal direction ante enti ra? Okay. So idena car re, okay, car or trolley, edaina you want, you can call it. Okay, acceleration of the car is a in the right side. Chuskondi andariki. Okay. It's okay. Okay. Yes, a little fun activity is encouraged, and it should not turn into spam. Okay. Yeah, what's the doubt? Sri Lakshmi, cheppu. What is the doubt? Tondarga. Now here we will take pendulum. Okay, pendulum. Alright, it's okay, right? It's okay. Sri Lakshmi, don't waste the time. What is the doubt? Tell me the doubt, okay? Tell me the doubt only. Okay. Hey, I'm skipping the doubt, okay? I'm skipping the chats now. Okay, imagine, hey, pendulum is there, ra. చూసుకోండి అందరికి. Hey, pendulum is there. Pendulum అంటే తెలుసా? Pendulum అంటే ఏంటిరా? Pendulum అంటే ఏంటిరా? Pendulum అంటే చెప్పండి అందరికి. What is pendulum, re? Pendulum is something like this. Okay. చెప్పు. Sir, there is this bob. This is known as bob, okay? Mass is there. Bob. This is bob. Mass emra. Ante gravity mg kindaki. Ante kada? Yes. Good. I'm only talking about Spandana because there is too much spam in the chat, okay? I can't see anyone's chat. Important messages are skipped. No, you are just doing see the chat, right? All the XYZ people are there in the chat box, except some good students who are actually listening to it. Next. Cheppandi re. Good students are also there, but some XYZ students are also there. So external acceleration is A in the right side, ra. Cheppo, pseudo acceleration, direction, left. Idena pseudo acceleration, ra. Pseudo acceleration kuda A. What is net acceleration, ra? Vectors. One acceleration towards right, one acceleration towards the bottom, ra. Cheppandi, 90 degree angle kada. Resultant of accelerations. Cheppandi. Sir, directly net is equals to root of a square plus b square plus 2ab cos theta. Theta 90 degree. Ante cos theta gone. Ante a square plus b square simply equals to a square plus g square. Ide. So, ide na net acceleration ra. Understanding, not understanding. Andariki cheppandi. Good. Very good. Okay. And I'm drawing the same diagram here also. Chuskondi andariki. So idena bob. Not bob. Bob is white color. Okay. Bob is white color. So idena bob ra. Okay. This is my bob. And the forces on the bob is not forces, accelerations. Chuskondi. G in the downward. Color ra. A in the left kada. Yes. So A in the left. Pseudo acceleration ra. Ante PA only. Net acceleration gurinchi cheppalante this is between them. Kani direction re. Angle kavali. Angle chuskondi. Shift this vector here. Cheppu. Sir, tan theta is equals to opposite side. Opposite side enti ra? Opposite side ante AP. AP ante acceleration of particle kada. Pseudo acceleration. AP ante pseudo acceleration divided by G ade. So ide na tan theta ki value ra. So that means the object or the string will also make the same angle theta for which tan theta is equals to acceleration pseudo divided by G ante kada. Based on this, it's a very simple question ra. Chuskondi. Pendulum bob tied to the moving car ceiling. Acceleration of the car is G root 3 ra. Chuskondi. So ide na car acceleration of car A is equals to G root 3 ante kada. Okay, find the angle made by the string with vertical ra. So ide na bob re. Hey, this is my bob re. And this is the angle made by the bob with the vertical. Initially the bob was something like this, okay? Something like this. So because this car is moving, the bob moves slightly backward. Okay? Yes. Not 30. Should be 60 degrees. Okay? Direct formula cheppura. What is tan theta? Pseudo acceleration by G. Pseudo acceleration entare? Opposite. Same. Pseudo acceleration AP is equals to G root 3. G value is G only. Ante kada. Tan theta is equals to pseudo acceleration ante G root 3 divided by gone. Tan theta is root 3. Theta value cheppandi andariki. Theta is equals to 60 ante pi by 3 radians or 60 degrees. It could be a PYQ also. I did not see PYQs for you. I know JE PYQs, but I don't know your NEET PYQs. So it might be there for your PYQ also. Okay, good. Yes, fine. Great. Next, hey, it's your exam level questions, ra. Huh? How 30, Ritik? How 30? Elara? How 30? Tan 30 is root 3 or 1 by root 3, Ritik. You are thinking from here or here, Ritik? Huh? Yeah, it's 60 degrees. Good. 60 degrees. Okay, Newton's second law. Should I take it? Yes. Energy undira. Huh? Are you all sitting with energy? No energy, sir. You are already tired, sir. 2 hours lecture. You are taking 2 hours, 15 minutes extra, sir. Why are you torturing us like this, sir? We are also humans, sir. We have also got lives, emotions, hearts. We have also got a lot of things, sir. Why are you torturing us? అదే కదా షూర్ సెకండ్ లా గురించి మాట్లాడుతున్నాం అందరికీ అర్థం చేసుకోండి ఓకే హాయ్ వీక్షిత హాయ్ 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 సెకండ్ లా స్టేట్స్ అబౌట్ ఫోర్స్ అండ్ మొమెంటం రిలేషన్ రా ఓకే it's not g by root 3 ray hey angle ray what is this ray g root 3 hey Ritik it is not g by root 3 ray it is g root 3 ray are you seeing some extra line Ritik are you seeing some extra line it is g by root 3 yeah g by root 3 you go to proper what should you say optical doctor it is g root 3 not g by root 3 Ritik. Okay if it is g by root 3 then 30 degrees correct okay good if it is g by root 3 30 degrees correct ra Newton's second law enti re Newton's second law talks about relation between Newton's second law talks about momentum and force relation statement I am writing okay hey statement చూసుకో రే force is the you are writing sir what are you writing 3 terms okay 3 terms ra momentum change of momentum rate of change of momentum both are different okay both are different yes what's your name SVM technology channel 6342 F is equals to MA but that is the end result ray you are not eating food and you are directly going okay 3 terms అర్థం చేసుకో first one is momentum అంటే ఏంటి సార్ mass into speed mass into velocity అర్థం చేసుకోండి రా 3 terms are there so sir Newton's second law states force is equals to rate of change of momentum dp by dt అంతే if you want to understand through equation రా ఇదే the equation కానీ అండర్స్టాండ్ 3 things ఫస్ట్ థింగ్ ఇస్ మొమెంటం దాని తర్వాత చేంజ్ ఇన్ మొమెంటం అండ్ దాని తర్వాత రేట్ ఆఫ్ చేంజ్ ఇన్ మొమెంటం చూద్దాం all of them will see it okay will see it Soumya why are you angry momentum అంటే ఏంటి సార్ momentum is represented by p it is equals to mass into velocity of the object అంతే కదా yes సార్ రెండు మొమెంటమ్స్ ఉంటే హౌ విల్ ఐ క్యాలిక్యులేట్ ద చేంజ్ ఇన్ దెమ్ రా చూసుకోండి సో సార్ p1 is equals to p1 అంటే ఇనిషియల్ మొమెంటమ్ ఆఫ్ పార్టికల్ యూ ఇమాజిన్ లైక్ దిస్ రా యూ ఇమాజిన్ లైక్ దిస్ ఓకే క్రికెట్ మ్యాచ్ ఇస్ గోయింగ్ ఆన్ ద bowler ఏంటి రా వాట్ bowler should I take I don't know you know the names or not okay yes the bowler has thrown the ball it came I hit చేసిన the direction and momentum got changed అంతే కదా initially momentum was something different అంటే speed was different mass was different coming I hit it speed got different direction is also different okay p1 is equals to m into v1 అంతే కదా right m into v1 రా. Similarly p2 అంటే m into v2 అంతే కదా. Yes. What is the m into v1, m into v2, p1, p2? చెప్పోరా. What are they? They are momentum of same object. Two different balls, two different. No, it's not like that. P1 అంటే సేమ్ ఆబ్జెక్ట్ కి మొమెంటం, P2 అంటే అదే ఆబ్జెక్ట్ కి మొమెంటం కానీ కొంచెం సమయం తర్వాత. అండర్స్టాండింగ్. సో మొమెంటం చేంజ్డ్ కదా. ఎస్. సో ఇమాజిన్ దేర్ వాస్ దిస్ బాల్ ఆఫ్ మాస్ 10 kg రా. అందరికి చూడండి రే. 10 kg బాల్ వాస్ దేర్. ఇట్ వాస్ మూవింగ్ విత్ ద స్పీడ్ ఆఫ్ u is equals to 10 meter per second. చెప్పోరా మొమెంటం ఎంతరా? మొమెంటం is equals to మాస్ ఇంటూ స్పీడ్ సార్. అంటే 100 kg meter per second అంతే కదా. దిస్ ఇస్ ద మొమెంటం ఇన్ ద రైట్ సైడ్. ఇప్పుడు ఐ హిట్ దిస్ బాల్ అప్ ఆర్ డౌన్. ఓకే, ఐ హిట్ దిస్ బాల్ ఇన్ ద డౌన్వర్డ్. సో హిట్ చేసిన తర్వాత ద మొమెంటం ఆఫ్ ద బాల్ నాట్ డౌన్వర్డ్ రే. ఓకే, యూ ఇమాజిన్. ఓకే, దిస్ ఇస్ ద బ్యాట్. సచిన్ తెండూల్కర్ రా. ఓకే, ఇట్ ఈస్ సచిన్ తెండూల్కర్. దిస్ ఇస్ ద బ్యాట్. హీ ఈస్ హోల్డింగ్ ఇట్. Ball came, hit, going back now. Okay, going back now. Same speed, right? Same speed. Let us say speed is equals to 10 meter per second. ఎక్కడ కూడా మాస్ ఇస్ అదే. మాస్ ఇస్ 10 kg. చెప్పండి అందరికి. ఫైనల్ మొమెంటం ఎంతరా? సార్ ఫైనల్ మొమెంటం ఇస్ ఈక్వల్స్ టు మాస్ ఇంటూ ఫైనల్ వెలాసిటీ. మాస్ ఇస్ 10, ఫైనల్ వెలాసిటీ ఇస్ 10 అంటే 100 ఇన్ ద లెఫ్ట్ సైడ్. ఎంత చేంజ్ వచ్చిందిరా? వాట్ ఈస్ ద చేంజ్ సార్? చేంజ్ ఇస్ 0. Why? Because the initial was 100, final was 100. 100 minus 100 is 0. అంతే కదా. చేంజ్ ఇన్ మొమెంటమ్ ఇస్ 0 రే. చేంజ్ ఇన్ మొమెంటమ్ ఇస్ 0 రే. ఎంత చేంజ్ రా? వాట్ ఈస్ ద చేంజ్ ఇన్ మొమెంటమ్? చెప్పండి అందరికి. చేంజ్ ఇన్ మొమెంటమ్ ఇస్ 0. హాయ్ రాణి. హాయ్. చేంజ్ ఇన్ మొమెంటమ్ ఇస్ 0 అంతే కదా. ఎందుకంటే సార్ ఇనీషియల్ మొమెంటమ్ 100, ఫైనల్ మొమెంటమ్ 100 కాబట్టి ఎన్ ఇస్ 0. నాట్ 0 రే. నాట్ 0. Imagine directions are also there, right? Directions are also there. Okay, how should I say you? Everything I only have to tell you. Delta momentum, delta P is equals to P2 bar minus P1 bar ra. P1 bar minus P2 bar. You understand? Whatever it's there. Okay? P2 bar value is 100 in the left side. Ante 100 into minus I cap ra. Minus P1 bar is 100 into plus I cap ra. Add చేసుకుంటే it comes out to be 200. Understanding? So this is change of momentum of the single object. A rate of change of momentum ante change in momentum divided by the time. Em time ra. To change the momentum, whatever time you took. Other Rani, you see the videos, dan tarvata let us talk. Okay, delta P by delta T. Delta T ante enti ra? Delta T is time to change the momentum. Hey, సాధారణంగా చెప్తున్నాను చూసుకోండి. Time to change the momentum is very less. You are throwing some object, you are hitting it with the bat. How much time is it contact with the battery? 0.1 second, 0.2 second. Generally, మామూలుగా delta T is in the range of 0.1 to 0.2 seconds. అంతే కదా. Understanding? Good. మామూలుగా the time to change the momentum is very small. అంటే తెలుసా అందరికి? In all these questions, you will get time as very small. Okay, very small. So, ide delta P by delta T is known as force. Ante enti sir? What you are telling, sir? Okay, చూసుకో. Ball of mass 250 gram moving with the speed of 4i meter per second collides with a wall during 0.2 seconds. చూసుకోండి. Time is 0.2 seconds. అంతే కదా. సో ఇదే నా వాల్ రే. So this is my wall. Idena ball. What is the mass of this ball, sir? Hey, mass of this ball, sir. What are you talking about? This is the ball. Speed entara 4 I cap. Mass m is equals to 250 gram. SI unit, is this SI unit of mass? No. No. SI unit is kg ante 1 by 4 kg ra. Directly raskondi. 1 by 4 kg is the mass. Okay, yes. Sir, mass going, hitting, coming back. So hit chesina tarvata, this ball is coming back ray, like this. What is the speed ray? 3I meter per second. Chusko. Minus 3I. Okay, opposite direction. Minus 3I. Okay, it should be minus 3I ray. So it should be minus 3I meter per second is the speed ra. Ante kada. What is the mass? 1 by 4 kg. Cheppandi. If the time of contact t is equals to 0.2 second, force kavali ra. What is the formula for force? Force is equals to change in momentum divided by change in time. Ante kada. Change in momentum entara. Initially momentum cheppu. 1 by 4 into 4 ante 1. 1 minus final momentum cheppu 1 by 4 into 3 ante minus 3 by 4. Add them, opposite directions, add them, divided by time is 0.2. Ante 7 by 4 by 0.2 ante kada. So 70 divided by 8. This is the force applied by the wall. Okay, good. M into V by T or M into delta V by delta T. You remember there are also 3 types. Okay, hey, చూసుకోండిరా. F is equals to delta P by delta T. Ante kada. Ante M into delta V divided by delta T. Leda delta M into V divided by delta T. Or it is equals to dP by dt. Here you must be good with differentiation. చూసుకోండిరా. There are 3 cases. Okay, here there are 3 cases. ekkada uchi it's a variable mass rocket system. Okay, used in rockets ra. Here it is change in speed. Collision type. Okay, collisions ra. So మూడు కూడా Newton's second law of motion లో వస్తుంది. All 3 of them are a part of Newton's second law of motion. అందరికి if any one of these gets asked to you, you remember how to do this. Okay, so we will start our tomorrow's class with this topic. Okay, Newton's second law of motion. Ante. So for now, let us take a leave ray. Okay, goodbye, bye bye, bye bye, bye bye. All of you have a good night. Sweet dreams and a very good night. Okay, ఏదైనా డౌట్స్ ఉంటే చెప్పండి లేదా leave the channel. Good night, good night, good night all of you. Good night. Good night. Thank you so much, Gunat. Bye, Spandana. Thank you so much, Parimala. Yes. Gitanjali, bye. Good night, Ritik. Good night. So here marks the end of this class.